So yeah, yeah. Hey Anwar,
Hey Shad,
how's
how's
it
it
going?
going? Good.
I'm doing well too.
Let's start over.
I've been working on a thing that I wanted to share with you. I've named it Shadow, which you know because you helped me make the icon.
Yeah, been waiting for your demo, so this is it.
It's preliminary demo. I ended up having to do so much work to just get it to this working state. And there's still quite a few bugs, but I think a demo is still in order. Let's talk about what it is first. So Shadow is basically a tool for macOS that kind of behaves like the Google Drive desktop tool or the OneDrive desktop tool or the Dropbox desktop tool. Do you know what that is, Anwar?
Yeah, I'm familiar with that, so if you wanna give more context, go
Sure.
ahead.
I will give context for audience. I would try to explain to people what it is that I was building. And the vast majority of people have not actually used any of those desktop clients. They use the web browser interface. What I'm going to do is demo what the desktop client does, and that will demo basically what my app is supposed to do. Let me show you what we're working with. So I have these files in my downloads folder. There's like a 1 gig file here of random data, some videos from my past music performances, and a text file. Let's say that I want to back up this data to Google Drive, for example. What I can do is I can open up a Finder window and then click on the Google Drive location in my favorites. And this Google Drive location here is provided by the Google Drive desktop client. I'm going to head to my drive, and then I have all my files here. I created this folder called Shadow for us. So if we go in there, it's empty. And what I can do is I can just grab all these files and copy them over to here. And then you see there's a little icon over here showing you that the different files are being uploaded. And
Yeah.
pretty quickly, the smallest files upload fast, and then there's the largest file is going to take a bit of time. It's going up. But crucially, if I open up the browser window, we can see that, there's some new files here. If I head over to my drive, Shadow, here you are, there are the files uploaded to Google Drive.
Works.
Yeah, good job, Google.
Yeah.
So the way that it works is that the Google Drive has implemented an Apple API called the NS File Provider API. And what this API does is it exposes certain hooks in Finder that allows Finder to ask Google Drive to fetch the contents of a folder, upload files, and download files. That's basically what it does. What I wanted to have was a tool that would allow me to do the exact same thing, but using an SSH connection.
Okay.
There are tools actually that already do this. And in fact, I bought a license for one of them. But for some reason, that one is very, very slow. I don't know why it's slow. And I've kind of wanted to play with this API. And so I decided I would build it myself for fun. Okay, enough talk. Let me show you the actual app now. So it's called Shadow. Here is Xcode. And I will just run my app. It starts off like this. So you have to basically create a connection.
Hmm.
So you go to the little plus button up there, and then you say create a new connection. And I have a Raspberry Pi running in my house, and it's named Avocado. So we'll just name our connection Avocado. And we can access it at avocado.local.
Nice.
And so when I'm on my personal network, this connection will work. But if you have a server on the internet, you can also point it to there,
Hmm.
and you can connect over SSH to that. Now, the remote path is the folder on the Raspberry Pi that I want to share. So we're going to point it to /mnt/shadow, which is a folder I've created already on the Raspberry Pi that will serve the files for the purposes of this demo. For authentication, the username is correct. It's using my Mac's username by default. And then to connect to my Raspberry Pi, I don't have a password. I need to use a private key, so toggle on the private key. We'll select a private key. There's mine. And that's it. So now we'll be able to enable the connection. But before we do that, a lot of what we're going to be doing involves looking at some logs. So I'm going to start the log monitoring.
Gotcha. So this is your MacBook.
This is my MacBook.
Okay.
We will have a terminal to my Raspberry Pi at some point. Maybe now. Why not now? Why not now? Let's open up another terminal. SSH2 avocado.local and mount shadow. I'll be doing a lot of this with the tree command. We're going to use tree to see the files here. So there's already a bunch of files here. So what we're going to do is we're going to connect. We're going to click the enable button. When we click connect, what's going to happen is Shadow is going to appear as a provider in this locations window. So let's go. Oh, gosh. I got distracted. We need to start the logs first.
We made a connection.
It's okay. There's the logs are running. Let's reconnect and do it again. Connect. And then Shadow appears. A bunch of stuff happens. We'll go over it. And then we can click on Shadow. And you can see the files that are there, right? So now if we come down to the tree view, we can see that, it matches, right? We got our documents folder, which is empty. If I click it, it's empty. I have another folder that has a file called demo.cast. And let's take a look at the logs. So here's the logs right now. You can see...
Do you mind scrolling up a little bit? So this log, what was the command you started to get this log?
Just log.
Oh, I've never seen that. So how does that work?
I have a just file. The logging that I've implemented is, I put a lot of time into it. And I think since you're interested, we can talk a little bit about that before we go down a little bit of a rabbit hole. I have a just file here, first of all. So my just file basically contains commands that I frequently run for the project. And so you can just say just space whatever. It's very, very similar to a make file, except that make files, in order to replicate this kind of behavior, you need a bunch of phonies because of the way that it's designed to work as a build system. It looks for like existing folders and stuff like that. Whereas I just want a command runner. And so just files do that. So when I say just log, it's running this command. And the reason I have to use this thing is that there's two parts to the way that the app works. There is the front end, which you saw running. And then there is the file provider extension, which is not part of my front end binary. That part is actually executed by the operating system in a separate process. And so if I were to close my app, the extension continues to run, making connections to the back end and continuing to do stuff even if the front end is gone. And unfortunately, what that means is Xcode does not show me any logs because the logs are being produced by the extension in another binary that was executed by the operating system. And so I have to look at the system logs to see my stuff, but my stuff is going to be mixed in with tons of other log messages. And so I need to filter the stream of log messages for the things that are related to my process.
Interesting.
So I have this complex logging thing that basically says stream from the system logs the things that are prefixed with this string here, format it as JSON and show level debug, and then pipe it to JQ and use this formatting from JQ called log filter. And then I have this other file called log filter that handles coloring for me. All of this was done for this demo to an extent. I did it mainly for me at the beginning, and then I improved it for the demo.
Yeah.
The main thing worth talking about here is all the different colors on these numbers. The operating system creates instances of my binary and calls it on from different threads. And so things that are related to one operation will all have the same thread ID. And that's sometimes hard to see because you get this interspersed log of things from different threads running against my binary, and sometimes you can't see one operation all by itself. So the purpose of the colors is to be able to more easily identify one sequence of things. Now, unfortunately, like I pick the colors at random, and so sometimes thread IDs that should be colored different end up being very similar.
I see.
But it's okay. For the most part, it doesn't happen that often.
That's very cool.
Question
Yeah,
answered?
very cool.
We were going to list some files in a folder. So if we looked at the tree again, demo.cast is here. So if I expand folder here, what we should see is that we're going to try and enumerate an FP item ID of folder, and then we should see it discover the cast file. So click it. Yeah, so there was a moment while it was trying to find it, and then down here we can see enumerating it, and then it discovered demo.cast, and then demo.cast appeared up here.
Okay. So those are actually just like a references? Are those like full files?
No.
They are a
Yes.
shadow.
They are that's right. They are a shadow of the real thing.
Yeah.
If you want to fetch it, you click this button here, or you interact with the file in any way.
Can you, if you rename it, for example?
If you rename it, it's not going to do what you think. It doesn't actually require a download. So let's rename random to random2. I'm just going to do it and you'll see what happens. So
Okay.
you can, let me make sure the log is, there we go. So the thing to look for here are the thread IDs that are important. And in fact, we only had one thread do all of the operations, 85976.
Oh, so it's trying to set attributes on the file remotely?
Mm-hmm. So the first thing it does is it does the rename. Yeah, that part's pretty obvious, no problem there. Then what it does is it sets the permissions. I don't know why it needs to do that, part of a rename, but I don't decide. The operating system asked me to do that. Then it tried to get the original file. That's what this log entry is saying. It's basically saying, give me the information for the file pointed to by this item ID called rand.dat. And rand.dat is gone, right? We renamed it. What I realized is the operating system, for some reason, is checking to ensure that the file actually went away.
Oh, that's what confused me too. Why is it looking for the old one? But that's cool that we were able to rename this without having to download them. I can see this is efficient for larger files.
Yeah. So I think that Apple's APIs, they're pretty well thought out. And I think the reason for that is because this is the second iteration of the API. They had a first version of the API, which I believe, I can't know for sure, but I think the Google Drive uses the initial version of this API. In the initial version, what the API looks like is basically your extension needs to manage its own set of files locally inside of its own container folder that Apple gives you when it spins up your binary. It's up to you to decide how you store the file. Like you can store it in a database, you can store it as actual files, like as whatever you want. The second version of this API, called the replicated extension, you don't maintain the file system yourself. Instead, the operating system asks you targeted questions about what the file system ought to look like, and then it decides overall what to display in Finder. What it means for me as a interface implementer is that I don't have to maintain a whole local. Yeah. But it does mean I have less control over overall how it's going to behave, which is fine because I want it to behave normally, like the way a normal file system would. And that's sort of the guarantee that I'm getting by implementing this version of the extension.
Yeah, that's very interesting. Like the way they did this, like you said, to control how do you want to display things, how do you want to render. You give them what they need, and then they make it work. Yeah, I do have questions come up to me, but we can discuss them later. Yeah.
Oh, there's nothing wrong with asking them now. Go ahead.
Yeah. Yeah, I just cannot stop but think about all these scenarios. Like this renaming is so interesting. So now, since you basically provided the way, you provided your API, and now Apple takes care of renaming nested files in a folder, like if I have a big folder with a bunch of files and I rename the root,
Yes.
does it also take care of linking those files to the new parents?
That's a very interesting question because I currently have a bug in my code that that particular question might exercise.
Yeah,
So let's rename folder to folder 2. Yeah, that's the bug.
I see.
The file disappeared, and you might get worried. It's like, oh no, where'd the file go? But if we look at the actual files on the Raspberry Pi, we can see that demo.cast is still in folder 2. And I
Okay.
think I know how to fix it. I was about to fix it before the demo, but then I was like, code freeze before a demo.
Yeah. No, definitely. Yeah. I was just curious if that's so basically it's something you need to think about and handle explicitly, right?
No, it's really just a bug in my code. In the meantime, I want this to fix itself for the demo, and what I do is I just delete and reinstate my extension. So the way that you can do that is by toggling this thing on and off. So let's turn it off, and then it goes away. Turn it back on again. Click on Shadow, and that causes it to resynchronize everything. And one thing you'll notice is that like things that we had downloaded before are now not downloaded anymore.
Hmm.
This is new.
Yeah, we discovered something new.
So documents is empty. I don't know why. Hold on. Let's just go back and forth. Okay. Yeah. Very new app. Bugs expected.
Absolutely, yeah.
Okay. So let's do a download because downloads are fun. So I have this 1 gig file here. And the purpose of having a 1 gig file here is to demonstrate the speedy downloads. So what we'll do is we'll click the download button and we get a little progress bar. And then down here, we're seeing the progress in text. I basically, every second, write some information about the progress of the download.
Nice. So is this using some kind of library or is it Apple providing this transfer mechanism?
It's using a library that I also wrote. Remember at the beginning, I told you that a tool like this does already exist, but it's very slow?
Hmm.
Yeah. So the reason why it's very slow, as I learned, is
Hmm.
that the people who wrote it probably I can't tell because I don't have their source code, but based on like behavior, I think that they're using Apple's SSH API. So Apple has an SSH API, or they don't specifically, but there's one called Citadel. Citadel, it's a Swift API for SSH. And I don't know why. I tried everything I could think of, and maybe if the developers, see this video, they may have some suggestions for me. But I tried everything, and I could not get Citadel to perform at the same speed as SCP.
Mm.
So what I did was I wrote a wrapper around Lib SSH, which is meant entirely for internal use of my app. It's called Swift Lib SSH. We can jump into that a little bit. Man, this is pretty deep stuff. We're going. All right. So here is the project. So Swift Lib SSH basically has. You know what? Let's look at the package.swift because I feel like it gives a good overview of the components. So we have these targets. The first target is clib SSH. And what clib SSH is, it's basically a compiled fat binary of lib SSH, like the C version of it. So basically, I have this build script over here, and it goes to the GitHub projects for OpenSSL and libSSH, downloads them, and compiles them for ARM and x86, and then produces a fat binary that it then copies into the source folder, and I check it in with GitHub. So I have libSSL, libSSH, and libcrypto. These are the three main binaries that I need, and these are fat binaries containing both Intel and ARM architectures. So from there, it's just a matter of wrapping all of Lib SSH calls. So I have this libssh.swift file, and this file basically is a wrapper around all the Lib SSH calls, starting from here, final actor SSH session. While I'm here, a thing that I learned, because I'm not actually a Swift programmer, I started programming Swift just for this project. Swift has this thing called an actor, which is a really fascinating thing. What it is, do you know what it is?
No, I don't know.
What an actor is basically, it's similar to a fully synchronized Java class, like where every method has the word synchronized on it. Meaning
I
to
actually
say,
don't know that too.
okay, no problem.
I haven't gone that deep in Java to know that.
I don't know that. I think you would be familiar with the C# version of this, but I don't know the C# version of this. So you'll have to tell our audience if you recognize it. But basically, because my library can be invoked from multiple threads, it is very important that no two underlying C functions from libssh get called interleaved. Like if one gets called, another one should not get called before the first one finishes.
I see. So it's like a synchronization mechanism.
Correct. And the way that these actors work is that there is a queue of things to execute that all execute on one thread. And when you call any method on this actor, it basically enqueues the operation, and then when the queue gets around to it, it executes it, and then you get back the response. But what that means is that calls to anything inside of this actor are going to cross some thread boundary. And because of that, all calls on an actor are going to be async, even if they're not defined as async.
I see.
So a good example of that might be like we have connect. And so connect calls the underlying libssh SSH connect function, right? And this connect gets called in my SSH client. Now notice that connect, it only throws. It's not marked async. But in this version of connect, it is async because I have to await session.connect.
Okay, I see.
The real thing that's happening here, Swift libssh, at the end of the day, is basically a thin wrapper around libssh. I try to basically hide the C complexity, right? The complexity that, we can't cross a thread boundary and that you need to free anything that you acquire. Like Swift by itself is a reference counted language. So like you don't usually have to worry about memory so long as you don't create any circular references. But the underlying C library will sometimes allocate memory for a struct. Like, for example, the attributes for a file. If I ask for the attributes for a file, it will allocate memory for the SFTP attributes. And then it's up to me to remember to call libssh's free command to release that memory.
I see. Okay.
So this whole library, all it's meant to do is thinly wrap libssh and hide the memory details.
Yeah. Yeah, that's very cool. Actually, I should probably open source this. I'm sure people might find it useful.
It is open. For everyone's information, Swift libssh is open source. I don't recommend anyone use it. I constantly make breaking API changes. Every time something doesn't work in Shadow, I fix whatever needs to get fixed, and I don't care if there's any consumers of Swift libssh for now. If people want to use it, that's the caveat. Be very careful. You're very likely to break between point releases. Secondly, Shadow is also open source. So the library is open source, and the app will also be open source. Before I get ahead of myself, I've been thinking a little bit about how I will release it. So I will put it on the App Store, and I will charge money for it there. But you'll be able to download a release off of GitHub for free. So I will build and publish it also to GitHub for free. Why would anyone pay for it? I don't know. I think there's only one benefit to paying for it, which would be that you'll get automatic updates
Hmm.
from Apple's App Store, but you won't get automatic updates from GitHub. You'll have to go and manually download new versions. So the real reason to buy it is, support me. But I think we're really far from there. I got too many bugs. So let's not, like I said, let's not get ahead of ourselves.
Yeah.
So let's see. I was going to demonstrate uploads and deleting files.
Yeah.
Yeah. So let's start by deleting a file because I have a file that we can delete, this 1 gig file. There's a folder inside of Mount Shadow called .trashes. I'm currently using this name because I noticed that it already existed, but I think it's a bad idea. I think Apple actually, if you plug in a USB drive into a Mac computer, it will create this folder to store trash data. I should not have reused it, but I was just moving quickly and I wasn't paying attention, so I need to rename that. But right now, you can see that it's empty. So what we'll do is we'll just trash this file. And I want the logs visible. Trash the file. So we can see that the trash is not a remove, it is a move. It's moving rand2.dat to .trashes / rand2.dat.
Interesting. And that trash is it's local to the folder where the file exists.
Correct.
Yeah, interesting. Okay.
Because now rand2.dat, which used to be here, has now moved into the trashes folder.
And so how do you restore this? Where do you go if you are a non-terminal user?
Oh yeah. So the standard way, right? You go to the trash and restore it. You can do Command Z. You can just do Command Z, comes back. And then if you look over here, it's move from the trashes back to here, right?
Mm.
I didn't do anything. Apple's APIs knew to call those functions. If I want to fully trash it though, completely delete it, I have to empty the trash. So we go to the trash here and we see some stuff there.
There
Hold
is
on.
an empty at the top right and under the.
Oh, okay, thanks. All right. So we go empty, empty. And then down here, we get a command to remove the file.
Wow, okay. Yeah,
And then
so
if we
basically the trash is just like a reference to where the file is. I always thought that the whole file moves to the trash.
yeah, exactly.
Yeah,
And if we look
interesting.
at the tree now, it's gone too.
Okay.
Okay. All right. The last thing for the demo is an upload. So let's upload this random.dat so that you can see an upload. Yeah?
Mm-hmm. Let's do that.
All right. Upload. We get the little progress bar up there. We see a little progress down here. Look at it go.
Nice.
Yeah, so like I said, part of the reason why I wrote Swift Lib SSH was to make it fast. And I was able to make it like significantly faster. So like nowadays when I do this copy and download, I'm saturating my own network, which is not that fast. But
Mm.
before it used to be the case that I would try to use that tool to back up like my YouTube videos, and it was insanely long. I would always revert to rsync because rsync would always work as fast as possible. So
So this is using the same underlying mechanism as rsync.
I think so. I'm not actually sure what if rsync uses lib SSH. But I know that lib SSH is very fast.
Yeah.
It's possible that rsync is using open SSH. Those are the two main libraries for SSH. So
Yeah.
it's one of those two. We can ask. Does rsync use lib SSH? Oh, yeah, it doesn't use either. I forgot. Because when you make an rsync command, it typically operates over the SSH channel, but it can operate over other things, right? So
Yeah, it probably has a client and a server mechanism.
yeah, so it invokes an rsync binary remotely, and
Yeah.
then it uses that. So the next thing that I wanted to do was I wanted to enable streaming. So let's say you have a VLC here, and I go into the videos here. None of these files are downloaded yet.
Mm-hmm.
It would be nice if you could stream them without necessarily downloading the whole file. So I've got a preliminary version of this implemented. Unfortunately, it doesn't work, but it partially works. So I'm going to show you the partially working thing. So let's watch this video. So you can see down here, it's not doing the standard download. What's happening is, I'm going to pause for a sec. I'm receiving requests from the Finder to play back pieces, to download pieces. So it's saying, download this range from, it's partially playing there. I don't know if you can hear it.
No.
Okay.
But I can see it, yeah.
It slightly moves, and so basically what it's doing, it's downloading a range and then feeding it to VLC for it to try and interpret it. Unfortunately, it's just going way too slow. But you see it keeps on doing it. It's downloading different ranges. The reason why it's so slow is, I'm going to just cancel this. The reason why it's so slow is that it can't pipeline the requests. So every time a request comes in that moment, I as quick as possible go and fetch that data and then respond, and then I get another request. But that round trip latency is way higher than the actual transfer speed, right? Even though I'm local on my own network here. So to make this fast, what I need to do is optimistically cache data ahead of time. So if I get a request to download this, I should know that the next one will probably be this. Why? Because I can take this and then add to it 32,768. And, well, it's not even this one. It's this one, 1032192, right? And so I kind of did a silly thing, right? I downloaded this extent, and then when it asked for this, I had it already, or at least part of it, so I could have gone and gotten more of it, right? Anyway, the solution to this is pretty straightforward. I need to basically do an optimistic caching, and then like fill up some queue to fetch data.
So if you optimistically downloaded something ahead, does it know that it has that locally, so it doesn't ask you to download it?
I have to do that. That's what I'm saying. I have to do that.
Okay.
Yeah. So because right now I'm not doing that. Right now, Apple calls my endpoint and says download this, and then it also says with this range. And then I don't have anything local. I never do. So what I do is I go and get it, return it to the operating system. What I need to do is actually start keeping some files locally, right? My current thought is SQLite database, you initialize with a sequence of extents. Well, I'm calling these ranges extents, right? Each one of these is like a block, a chunk, whatever. A sequence of these chunks that are in the expected chunk size that the operating system typically asks for. And then when I get a request for one, I download that one, but I also queue up another download for an additional chunk. And basically, like if I get a request, before immediately fetching it, I go and check my local store to see if I have a cache hit for it, return it.
Interesting, yeah. So when you get asked, you decide whether to serve it locally, which is much faster, or download it.
Correct. Yeah, correct. Yeah. Now, the interesting thing is that the API for this particular part of the file provider, it asks for this range, but I can return to the operating system saying what range is actually available already, right? So that could mitigate how many requests come to the extension in the first place. So let's say it asks for like 10 to 20, and then I say, actually, here's 0 to 100. Instead of asking me for 20 to 30, it will just know that 20 to 30 is there, and it will just read those things. So if I have a SQLite, it doesn't have to be a SQLite database. If I have some data structure storing which chunks are available and which chunks are not. When the operating system asks for a specific chunk, I can just expand it to and return the full set of chunks that are actually available. And for the record, like 23 megabytes is nothing. That's what I tried to stream. If I were to click this button, it's like done, you know?
Yeah.
You know?
Like if you potentially buffered the whole stream, the whole file, and you close VLC, do you end up downloading that file there?
Yes. Yes, to an extent. I have never sat down and waited to see if an entire file would eventually download the whole thing. As you saw, it's downloading like 32 kilobytes at a time.
The question basically, account the does it count for downloading a file when you stream some of it?
Yeah. And what I was trying to say is I don't know because I never waited to the end to
Yeah.
see if when it finished all 32 kilobyte chunks, if it just marks the file as downloaded, you know. I anticipate that it would have, but I didn't have any video files small enough to test. I mean, I could. It's just that I figured I would just make it fast. Then we'd know for sure. Like this partial fetch function is optional. You don't like it's not a required implementation for my extension to work. If I don't have it, the operating system defaults to downloading the whole file. And that would be fine, right? In the
Yeah.
case of these smaller files, it would be way faster. So, I mean, if this was a released product that didn't have bugs in it and I didn't have this feature yet, I would work to implement the partial fetch. Let's say that you have a video file. And this is a use case that I do have in mind because I wanted to use this tool to help me with my YouTube production. So one of the things that it should do is allow me to scrub through video files that I have remotely. The problem with scrubbing is that I will get a whole bunch of requests for different parts of the file. If I am queuing up optimistic requests, those optimistic requests might be invalid by the time I've scrubbed somewhere else, right? And if that's the case, then I should invalidate these optimistic requests and prioritize where the user has scrubbed to, right? And so in some sense, like what I might want to do is do something like have a queue that if the user scrubs, flush the queue and prioritize whatever comes in next, something like that.
Yeah. This reminds me of a UDP protocol, basically, or trying to re-implement the same thing.
Yeah, exactly. Which is a pain.
Yeah. Yeah, very much so. But
Yeah.
yeah, that's interesting. So now so now assuming this Zelda Tango was downloaded,
Yeah.
if you rename it or if it was modified on the Raspberry Pi side, does it
Yeah.
refresh?
No, not yet. That is a thing I want to build. In order for that to work, I need notifications server side. The thing is, the app that I'm building by its nature doesn't have a server side component. In order to do that, the way that you typically are supposed to do it is the server will emit some notification that will trigger my app to do a local cache invalidation. And then from there, like the operating system will then know to re-download those files for the latest changes or create a conflict if it was modified locally when the remote side received the change. So how will I do that? The answer is I can do notifications, but I can only do it when the user is online, right? Because there is no server-side process. So the only way to get this to work is establish a connection to the server, then run some command that can monitor for file changes. And then like fswatch, for example, which is the way I was planning to do it. And then when fswatch emits a change, I can trigger a local cache invalidation. But if the user is not currently, their computer is not on, and then the file changes, there is no file watch, which means that I need a separate process where when you reconnect, I have to do a scan to see if there's any difference between a local understanding of what the file system should be. And what that means is storing metadata about the remote file system to compare against later. That's also a pain.
Yeah.
Both are on the roadmap, but they're both hard problems. For the moment, it would be nice to just get like online changes working, because a simple thing you can do is just invalidate the entire local cache every time you reconnect, right? And then it will create conflicts galore because every change you made offline will then become a conflict, but it will at least be correct, correct for some definition of correct, more correct, I guess, than not noticing that there's a difference.
It is interesting. Thank you for going showing me the process. Now I have an idea.
Yeah, thanks for spending 2 hours with me to talk about this.
Yeah, absolutely.
You want to tell our viewers what they should do?
Yeah, smash the like button and like and subscribe. Did I get it right?
Yeah. I mean, yeah.
Nice.
Yep. Bye bye, internets.
Bye.